All right, let's get a sound check here. It's interesting. OBS Studio has updated itself, so the sound is kind of weird, but it looks like you guys should be able to hear me. How's it going, Samantha Nakamoto over on the Twitch side? Hopefully this stuff's useful to you. I am just getting back into this, so kind of orienting myself. Last week earlier this week, I was out in Ohio training some users. Well, I was actually training admins, so not really users, but admins on a cluster of supercomputers that we built. So 3 different clusters of each one of them is their own supercomputer. So we'll talk about that a little bit. I'm going to build some stuff out here and kind of run through some stuff. Let me get into my little normal streaming setup here. I might need to adjust my light here just a little bit. That might be pretty good. Okay. So, yeah, you guys haven't seen me. I don't think I've been streaming. I don't even know if I've streamed all of March and barely any in February. So I'm getting back to it. I've been kind of busy with a lot of stuff. I'm a candidate for my PhD now, so that's moving right along. That just means that I'm in like the last couple of things before I go and defend my dissertation and do all of that stuff. I haven't been working on that nearly as much as I should either, but that should be changing these next few weeks. Let me grab my notebook here. Engineers, keep a notebook, right? All right, so as I sit here and as I kind of orient myself to what I was doing today, I wanted to talk a little bit about the courses that we've been working on. We should be almost done with those, but also I kind of thought about talking a little bit about supercomputers, because if we're doing high performance compute a little bit, we can go hop in here and draw a little bit out on that. Can make a new one of these, I think. Let's just start drawing. Boom. You guys ever played with Excalidraw? Great tool. Fantastic tool for what it is and kind of what's going on in here. But what I was going to show you guys a little bit is a lot of times when we build supercomputers, what I was saying is, you'll have your primary, this will be like primary HPC system. And the thing about, your primary system, if it's sitting over here kind of doing whatever, it's going to do the bulk of like your production jobs. And it's going to do, there's going to be some other things it's going to do. But then typically what we'll have is we'll take this whole thing and we'll make a smaller version of it. And this will be our dev HPC system. And this one will be a lot smaller scale. Maybe think of this thing as like somewhere, and this will be test jobs, research, or let's say dev build environment, right? So something like that. And this will typically be about, if I had to roughly guess, maybe about 20%, or maybe even a little less, the size of primary, right? So you've got some dev HPC system over here. And then we've got this other one that we build that's kind of funny. And this one is, in this space, this one is really, he's still running, but this one is just a parts HPC system. And typically of the primary, it's only going to be about 5%, if I had to guess. And you don't really do any of this stuff on it. What you kind of do out here is just run jobs. And you keep everything running over here. And you might say, well, Scott, why would you have, if you were building a HPC system, and let's say the life cycle or approximate lifetime is equal to, let's say, 5 to 8 years, and some go all the way up to 10, right? So some all the way up to 10 years, right? How fast do vendors? Hey, Colcus, how's it going? How fast do vendors kind of refresh their hardware and go to new hardware? Anybody know that? Anybody here work with vendors like Dell or like Nvidia? Like, I just want you guys to think about this. How fast? So here's a question for you, and it's this: how fast do vendors, or system manufacturers, how fast do vendors, system manufacturers, obsolete or EOL, end of life, parts? How fast do they do that? Does anybody know? I mean, and it's going to be different for different vendors or whatever. But one of the reasons we always have this part system over here is this specific problem of how we use things, and it's this idea that you're over here running a system that you expect to live 5 to 8, maybe even 10 years. And some, I mean, I'm running a cluster that's it's not being replaced in time, so it's going to keep going longer. Well, think about this. Are you going to be able to get those parts from the vendor anymore? No. So what we do a lot of times, and it's actually the term we use, is we cannibalize the other systems, because the primary system has to keep running. The prod system, this has to stay running, right? This is where the money's made. This is where the research is done. Like, at the end of the day, this is where the big parts of what goes to the users or the stakeholders or whatever are going to keep happening. So we want a part system that, and you might say, why don't you just keep a parts locker? Why don't you just keep, because we do keep parts lockers. But what happens is, especially with older equipment, some of you guys have fired up stuff out of your closet years later, systems that aren't running, is it going to come up or not? Who knows? So a lot of times we just keep things running in here, and then we use this to swap out parts of devices that we need. But it's a very small subset, but it tends to be, it'll be a calculated size typically between what we call the MTBF, mean time between failures of parts. And we'll calculate out that with normal failures of parts out here, this should be able to replace those parts for us, even if we can't get them from the vendor. And you say, well, doesn't this thing just look like a beat up, like an old box of parts, like an old spare parts box that you just pull stuff out of to keep this one? Yeah, that's pretty much what this looks like. And after a while, this one just looks real chewed up and is barely going, but we still use it to pull discs out of, to pull whole chassis out of. You'll pull motherboards out of this to replace out of different hardware that you have and that kind of stuff. But you say, well, but why don't you just go to whatever the new vendor thing that comes out? Like, why don't you just go to that? Like, you could just, the vendors have new stuff, and you say, yeah, but one of the problems with not one of the problems, but when you deal with high performance compute and you're doing research and also big jobs, is you need a precision. You need the same exact ratio between CPU and memory on all of your boxes. And you say, well, I can get that with the newer stuff. Yeah, sometimes you can. Sometimes it'll be a little different. You don't want to create Frankenstein's monster, right? And Frankenstein's monster is this thing that's just stitched together. I know most people will just say Frankenstein, and that's fine. He doesn't care. The monster himself doesn't care. But technically, you don't want to create a Frankenstein's monster of stuff, right? Right? We got to be technically correct. Sometimes we got to be a little pedantic here. But anyway, so this is kind of a thing I was thinking about. I've been again. I spent about 32 hours Monday through Thursday in Ohio training users on one of our big systems for high performance compute, and this is the general idea of how we build it. So it's 3 individual supercomputers, and each one of those supercomputers looks like this, right? Each one of them looks like this, and in fact, I think I can go grab this here. I'll link this for anybody that wants it. Let's see. I don't know if anybody's I don't even know, besides Colchis and Samantha, I don't know if anybody's even paying attention. But this is a draft that I really like. Even though it says up here at the top it's withdrawn, this is still a fantastic thing to understand if you want to get into the high performance compute space. So, HPC right here. We can go grab this first picture. This is just a fantastic little picture for what we build. And when I do put together the course, which one of my goals today is to finish the automation course so that I can turn around and start focusing on this one. And this course here is going to be So let's go back over here. I think I can paste this. Let's see. Whoops, can I? Oh, damn it. Where's my... Gotta grab it again. Because I accidentally hit Control-C in the wrong window and immediately lost my paste buffer. So that's annoying. Alright, there we go. And I don't know enough about Windows to be able to go find older things in the paste buffer. So, alright. We'll leave it open this time. I won't close it. There we go. Now we have it in the background. Where's this? Here. Here. Bam. I think I could just drop this here. So this is what's going on inside of any cluster. So each one of these is adhering roughly to this. Although it is interesting, typically your dev system will have this connection out. So the connection that goes out to the outside world is an air gap system. But this one right here, so this will have air gapped connections exist for users, right? That is true here. It is true here a lot of times because dev environment is where they build stuff and they test their code and do other stuff like that. So that is there. But air gap does not exist for this. Typically, only admins can remote access this cluster. And that's just kind of a thing that we build or a way that we think about this. Oh, there we go. So this is something that we'll be kind of digging into more when we get around to doing the automation stuff. Colgus said, I think paste buffer is a setting you have to... Yeah, and I don't even... I mean, I basically, if I can't Control-C it... And what happened was I clicked in here and I accidentally hit Control-C with my hand. I just kind of do it like this instead of Control-V. So I just missed it myself. That was me being dumb. So what I have to do then... is finish up. What I want to do is I want to get those worksheets to the guys. So all the worksheets are done with the exception of I don't have the lab links created yet. So really what I need to do is just come in here, put together all the lab links so that I know what they are, so then I can just update them even if the labs aren't completely done on time, or the labs won't be completely done by the time that I do that. And I'll just get the labs going here too. That'll be another thing for me to kind of work on today. And then I'm only going to be on for a little bit this morning because I'm working. I got some college stuff to do here, and then I might be back on later tonight because the wife has taken one of our nieces to a play, and sometimes I go to the plays with her, but tonight I'm probably just going to keep working on college stuff. So let her go do that. We've been hanging out in Ohio for a whole week, so we could we could use some downtime as well, which is, I mean, it's still good to spend time with each other, but we don't have to spend all that time together. All right, but if anybody has questions, I also thought today to go over a little bit of Ansible, but I probably want to finish these up first because I do want to finish up the questions and get this stuff done. Where are we at here? This was updating, so that's all right. And the lab link, so the actual path. Can't get my stupid mouse to work. Killer Coda. Let's go grab the actual link that we'll be using here. What is that? Open Boo. Open Bow? I don't even know what that is. Sorry, I'm distracted now. I want to see. Deal with audit device failure. Oh, it's an open source community driven fork of Vault. We might have to play with that, guys. I feel pretty good about my my Vault foo as far as that goes. So that's, oh, all right. I've gone down a rabbit hole now. Hold on. So we can do this in, okay. That might be all right, that's something to play with later. I'm getting distracted. That is interesting though. If anybody wants to go look at that, I think that's a fun one. I might drop that in our. Let's pull this up. Oh, other things to note too while we're kind of hanging out here. We can always go here and see the events that are coming up. So in about 2.5 hours, we got a Bash study group. Colchis runs that. If he's not around, somebody else will typically pick it up, but you guys can go in there, talk shop with other engineers and or admins. Let me move this up a little bit so you guys can see chat. There we go. It's better for chat. Linux admin course is today at 3 p.m. So we'll be going through that. We should be in, oh shoot, we're in week 4. So it should be 7 and 8 this week. So, I mean, that's moving along pretty fast. And then Linux from scratch is also another thing Colchis is running. That comes directly from the book. I meant to ask Colchis, I don't know if you're still around, but you can put the LFS, since that's a book that's just available to anybody, it's open, you know, it's, I don't know if they released it Creative Commons or whatever. You could actually drop the link in here if you wanted. But anyways, that's the events that are coming up, guys. Yeah, so these are all the things that are coming up. Everything's free in our Discord. You guys can just go hang out with people, talk shop. We're almost up to, did we hit 4,800? I'm not sure if we hit. We're almost to 4,800. We'll be at 5,000 soon, hopefully. That's kind of what we do around here, is just show people Linux. And oh, what I wanted to do was go here and say, typically under DevOps, anybody used, there we go. All right, so let's go find our environment, and we'll find the automation stuff. And then what we're gonna need is, we're gonna need 11, but 11 will be a link just like this. So let's go back one. 11 will look like this for the link. It'll be there, and then it'll be unit 11. It'll be this path right here. All right, boom. That'll be the actual link. So then if we go here, digging deeper, components of drawing on doc, yeah, that's fine. Okay, so we're gonna call 11 good, or file, save it as, we're gonna make this a PDF, right? So, save. And then we'll get out of there. And then what I can do is, back in the Discord, I can drop this. Man, I have so much stuff going on in my history that I have to go find it. This is the, automation course. Should be in unit 11. It should be this PDF. We just made it. Oh, whoops. I want to drop it there. I want to go drop it in the writer's room. Unit 11. Boom. All right. Labs. All right, labs are there, but not working yet. All right, so then we go to the next one. This is pretty much the bulk of what I'm working on today. Unless you guys want me to work on anything else, just let me know. So here's automation unit 2, or 12 rather. And then here was our discussion. So this one was around touching networking devices, and we were specifically using Ansible and this iOS configs file. And what we were doing was talking about how you would use Ansible to connect those boxes. The lab for this isn't completely done yet, because I want to set up, in Kubernetes, you can set up basically just a CLI that will just respond to things and pretend to be a Cisco router. And I just haven't gotten around to making that work yet, right? But I can deploy that in the Kubernetes environment. And then what I want you guys to be able to do is just back up or send a config into a system. So here's an example of what it would look like. Super easy commands. The module is just cisco.ios.ios_config. And you can add lines into an access list if you wanted. You could push or pull configs into or out of the system. And there's all kinds of tools to do this. Don't get me wrong. Like you might say, well, isn't there a tool that's been around? I think it's called like Archer or something. Been around since the early 2000s that'll just go and pull all your configs out of your network devices. Yeah, that's sure, but that's an expensive tool. That's like a proprietary tool. Your company has to go spend money. A lot of us that are in the Linux space, we have to do a lot of powerful things with just what we have. So I call it like the poor man's configs or the poor man's backups. Some of the stuff that we write is just we go and just figure out how to do it. So anyways, there's that. And then the other part of this was you've read about software-defined networking, but maybe you haven't used it before, so then you do a little write-up on that. We don't want the core one. We want, hold on, we need a different one for this. So we need the Ansible Cisco module. So here's the Ansible Cisco module here. iOS. And by the way, iOS was Cisco well before Apple ever even thought about doing any of that stuff. Well before Apple ever thought about that name. Let's go look at this real quick. If anybody needs this, this is the documentation. I'm a big fan of just digging in on docs like this, and I'll just come down and steal any of the things I need. So if I needed like my iOS, what was one we were just looking at? Anyways, here's all the different modules that you might need. Got a nice little VLANs module. Go set or activate your VLANs, which by the way is important if you ever get into stigging networks. So, you know, I do high performance compute stuff. I do Linux, right? But I also have to touch a lot of the switching in there. And one of the STIG standards you'll always find is you can't be on the default VLAN. Default VLAN on Cisco devices is 1, but it doesn't matter what the default is. Whatever that default is, the STIG standard says your networking, specifically your management devices and your management traffic, can't pass over a default VLAN. Meaning you just have to pick a VLAN like 10 or 100 or whatever you want outside of the range that you don't have to do that. Watchmakering, good morning. Have you ever done CTFs? I've been trying to get into them more. Yeah, watchmakering, I haven't done a CTF since they started calling them CTFs. I used to do what we called rooting servers back in the day. We used to have root competitions, and we would like take over servers on the internet that were available. I mean, obviously, back in the day, before the laws changed in the early 2000s, there was no actual law against rooting boxes. It's just you weren't supposed to do it. But yeah, we used to do that. We used to call them root competitions or just root this box. Nowadays, they're all capture the flags and hack the box and stuff. But I'm not trying to sound like old or elite. I'm definitely very old. I'm just saying I haven't really... my career took a path away from like just being strictly security. In that, I honestly, to say it in the most crass but accurate way I can, I just hated getting into meetings with security guys and being a security guy. And every meeting was just us having dick measuring contests to see who had the biggest, you know, who knew the most about security. And I'm just like, oh fuck, can we just get back to work? So that's one of the reasons I've kind of stayed more over on the engineering side, is because I just would, and I would always bump heads and clash with those guys in meetings because a lot of times they didn't understand like the underlying how we did stuff in the systems world. One example of this, and I've fought with, this is probably the biggest fight I've had with security teams over the years, is like you can't have a backup Linux kernel because the backup Linux kernel on a box still triggers all your vulnerabilities. Qualys, Nessus scans, any of those tools. Nessus comes from Tenable, Qualys has their Qualys Inspector or whatever. When you deal with those guys, they'll be like, well, you can't have that kernel in our environment because that kernel introduces these vulnerabilities. And you go, okay, fair. I'll remove all the kernels. But here's the thing, when you're not running on the kernel's only there to be able to get the server back up. Like if something crashes on an update or something, we always keep in the operational world and in the enterprise world, we always keep one version of the kernel back. But that version of the kernel is always going to be having more published vulnerabilities for it, right? So, you know, security is going to be yelling harder because they're like, hey, that thing's got vulnerabilities. And you're like, it's not running. There's no vulnerabilities. They're like, yeah, but you might turn it on one day. And you're like, yeah, but only when the box is like epically crashed and we're trying to get up to get to the other. So anyways, that's like a fight. It's like, it's the idea. It's the same thing. It's the same thing in the academic world. We can push over Ethernet like over copper Ethernet, we can push way higher speeds than we can push in like a stable in actual environment and with a cable that's longer than like a foot, right? We typically deal in meters when we talk about cables, but I'm saying like we can push massive amount of speeds over cables this long. What? But that's not even theoretical. That's actual. We can do it. It's just that's not practical in an enterprise, because what are you gonna do? Put your backs of your racks together and just have those and then they're just gonna blow exhaust on each other and burn themselves up at 170 degrees or whatever. That's Fahrenheit for everybody. But Colkus said we're doing some capture flag-esque labs later today in the Bash Play group. Nice. Yeah. Did you guys ever finish how to over the wire go, Colkus? I didn't keep up on it. A lot of times I will see that the groups are running, so you guys know, and then I don't jump down in them because I don't want to derail what's going on in the meeting, right? Sometimes I do, but typically like later on in meetings. And I do that because I want the people to be focused on the group or whatever they're doing. I've been telling people since the beginning of this group, and you can go ask people even before we got on Discord, this was never supposed to be the Scott show, right? It's never supposed to have been about Het. It's supposed to be you guys doing this stuff and getting better. Yeah, optimization isn't AI a thing that fixes all? Yeah. AI will... AI is a lot like Mr. Meeseeks. If you guys are ever in the Discord, you'll see that I use Mr. Meeseeks as my... It doesn't know how to do... Okay. Mr. Meeseeks is a character from the first season. Well, I guess he's in other seasons, but the first season of Rick and Morty. And he decides to get... He can accomplish a mission and then he ceases to exist, right? And the funny thing about it... How's it going, Northern Chimp? I am kind of just going through stuff and building stuff as we talk. But where I'm going with that is... Mr. Meeseeks can't fix Jerry's golf game because Jerry's an idiot. So he decides to take 2 strokes off his golf game, which is the request, by taking all the strokes off his golf game by killing him. So technically, that's the best way to do it. So, anyways, yeah. So bandit stuff. Colkus was doing most of the bandit stuff, so that was kind of cool. A couple of challenging ones. Yeah. Colkus. I think a lot of that stuff's really good for people. Who was doing Sending Grounds did Bandit a while ago too, but Sending Grounds hasn't been streaming either. Of course, I can't say anything. I haven't been streaming much either, so we're back at it. But Northern Chimp, yeah, we're working on Linux, right, over on the YouTube side, doing as much Linux as we can. All right, so terminology around this is going to be SDN, and then it's going to be hold on, let me go look at my... I know I have notes on this somewhere, but control plane and then network. Typically with SDNs we have a control plane, and I forget what that other one is right off, but let's go I'd say that's the major term for that. Software defined networking. Any other term, let's say there you go. Any other related terminology is good. And then the lab for this one is going to be... Oops. Let's make a lab for this one. It'll be 12 networking devices. There we go. And we're going to be doing a few other ones too, so I'm not too worried about this. I do need to go grab my... Let me add hyperlink. Typically got to point the hyperlink at the right place too. Okay, that should be good then. And then read the other parts of this. So for this one, it's more of a software-defined networking. Actually, no, it might be a good one to look at for this is networking plumbing guides. This might be a good one for people that want to read other parts. Read about a SDN tool is useful. So if you guys have never used Pulumi is just kind of it's a lot like Terraform, but it's in more of a software uh, generated way. So Pulumi interacts with some of these other tools a little more robust. Make sure I'm not missing anything. Mr. Beast, disrupt the IT space for $20, even though it takes. yeah. All right, let's go. So this one, well, let me go look real quick. So, lab is 12, and it's networking, network automation, and we're gonna just call that network devices. There. Okay, that's all right. So, home file, save as. We're gonna turn this into a PDF. Get this one out of the way. Go back over here, writer's room. We're gonna say PDF 11, 12. Automation worksheet. All right. Even though the links are broken right now technically, but they'll get better. They'll get better as I go. I gotta publish this still. This all has to get pushed to Git, and I have to go make all those. So we'll get to that. What's my next one? 13. 13 is pretty much done too. It's automation, and it was around your management has been discussing ways to reduce errors in your current Wild West environment. If you guys haven't gotten to play around in a Wild West environment, they're fun because admin is just Wild West, but they're terrible in that there's no documentation. Everybody's just changing stuff with no control. So in that sense, they're very terrible. But they're fun when you first start. But then you get to more lockdown environments and you can't do that kind of crap anymore. We're going to review the SRE guide to treating configurations as code, and then we're going to learn some about the practical advice section. Okay, so that's good. We'll skip the terminology on this one. We don't need the core module for this week. That's fine. A lot of times these lectures and stuff are just for you guys when we were walking through and doing stuff. So terminology, CMDB. You're going to have those are things to think about. You're going to have a bunch of different types of change management things that are going to happen in a company, and they're going to bother you a lot, but then hopefully as you keep doing this stuff, it'll get better. Like I always just tell people, I just want to be kind of riding the wave. I don't want to be great at change management. I just want to do enough to make my engineering life easier. But change management is you're going to have engineering change boards or ECBs. You're going to have change advisory boards or cabs, and this is just what your company calls it. I've seen ECBs also be called electronic change boards because they're doing it remotely, but that's typical things that you're going to find. You're going to get change windows often, or downtime windows sometimes. And then there's just a bunch of stuff like that. And I when we did the talk, so you guys are just seeing the worksheets here. When we did the actual talks, we went more into it. And I need to finish these up so that I can get them in the discussion. So then when I do the recordings, I have it all kind of like everything will be pushed through. I'll move this up a little bit. Can I ask something stupid? I learned bare bones C in uni. If we were talking about kernel design, can we use Rust? So Lampfowl, actually, we were just looking at kernels on Wednesday, me and one of the guys in the course, because I was out in Ohio training people. And we were looking at the percentage. You can see the most recent version because Linux is coming out with kernel 7. They've been really aggressive with like 5, 6, and 7 have come out pretty quick compared to how long the life of Linux is to be going to 7 already. But the 7 kernel is I think 0.2% Rust now. So you can go look at that if you want. But it's funny. It used to be all C. But as far as kernel design and Rust is becoming more viable. And I have seen full ports of core utils to Rust that works in a normal on a normal Linux 6 kernel. So like Rocky systems, Rocky Type 9 and those type of systems. Let's check that actually. Are we on 6? Oh, since I've come home, I have not hooked up I have not connected back into my jump box. Let's see. From this box, screen -R, let's reconnect. And then let's go look. So we were checking some different stuff. When I was remote, I was actually using my home lab as well as one of our clusters for the customer to show some stuff. What did I want to show you? Oh, uname -R. Oh, Prometheus. My Prometheus box on a different environment. I'm kind of. Let's just go over. Let's go over to my actual werewolf environment. Yeah, that's still. I could have sworn Rocky was on 6. What do I have in my environment that's on 6 then? Let's go see. He's here. Oh shoot, I guess I don't have... I could have sworn I had some stuff out there on 6 kernel. I guess not. Alright, well, whatever. But yeah, they definitely have that lamp file. You can definitely get into... There are whole communities of Rust rewriting those libraries, like the core utils, and a bunch of libraries inside of Linux are being written over for Rust. So the kernel is also a viable option. Modules are being written over there now. It's a larger percentage in the new version of the kernel than it's ever been. Let me just go look real quick. Let me see if I can grab this real quick. Let's just go pull this right here. This is Linus Torvalds. I think we have... Yeah, I think right here. Yeah, it's a very small percentage, but Rust is starting to be in there. And we could go look at a specific version of Linux here. But yeah, the Linux sources, there's a small amount of Rust in there for sure. So, hey, Haku, how's it going? I haven't been on for a while, so I thought I'd hop in for a little bit. I got some stuff to do with my college students it's almost 8 a.m. my time, around 11. So 11 to 1, I go hang out with all my college students, talk college stuff. And then, oh wow, there's all kinds of stuff going on in here. Yeah. But yeah, you can get in there. You can be a contributor if you want. Go mess around with that stuff. All right. But that's not what we're doing here necessarily. We're just finishing this up. Securing modern Linux is no longer... So for 13, we are dealing with the concepts of CMDB, and I believe it's actually change detection. So let's go look in the course real quick. LAC. So here's the administrator course, which I'll be doing later. And let's go look at the automation course. Syllabus. If you guys ever need any of this stuff, it's all online, right? 13 is remediating and reporting on drift. So let's just call the lab. Oh, that's terrible. Remediating drift. Oops, drift with a T. And we'll do the same basic thing that we just did over there. We'll call it unit 13, remediating drift. Fix that. And then we'll go in. You gotta edit the hyperlink itself, because again, word. So Linux 13. Drift, if I could spell. We don't need that. We'll leave the digging deeper. Let me think. How does AWS so how do you remediate drift in systems? Well, gotta have a tool for it, and they talk about it in there. All right, so 13 is gonna be good. PDF. Boom. We get that out of the way. Back here. Go to 13. Go drop 13 over there. And obviously we can do smaller changes if we need to in the system. That kind of stuff. Is it async handling or something else? I'm a Java spinning dev that got laid off. I'm gonna code things like now. Yeah, Lampfowl. I mean, most of my stuff is, you know, the lower level Linux stuff, but I try to get a place where people can work on whatever's interesting to them too. So hopefully that stuff is good. Watchmaker in the talk about Rust with a group of Linux files. Oh, I didn't see that. No, I have been, I don't want to say like shut off, but I've been definitely like off the internet a little more, working on that stuff. Oh shoot, the wife texted me. Apparently I didn't get it. Yes, gosh. I know this is super late. I didn't see that the wife texted me a little while ago. Well, I gotta yell for her. Hey wifey, are you still here? Are you gonna go? I just saw your text. I apologize. Yep. I'll text you. Okay. Good. Wife plus ignoring social media. Yeah. Well, no, we spent this whole week together in Ohio. So I was saying today how it's kind of nice that we'll decompress a little bit. Oh, and who mentioned me? Somebody mentioned me up here. Oh, that was probably just, yeah. So I haven't streamed so long. We can actually go see the last time I streamed. When's the last time I streamed? It's been a while. Other people, anybody can tag anybody in there. Oh shoot, I haven't streamed since the 24th of February. Damn, that's been almost a month off. All right, well, but we're back at it, right? Ohio. So when I went to Ohio in January of last year in 2025, it was the biggest blizzard that they had on record. That was terrible, and I flew directly into Columbus, or Dayton. I flew directly into Dayton right in that storm, and then this time they didn't quite have a blizzard, but it was pretty cold when I was out there. I saw some zeros with wind chill. Without wind chill, I think it was like in the 22 one morning, but then with wind chill it was dropping because we were having like 60-mile-an-hour gusts, but the sustained I think was almost 30 at some point. So it was wild. But yeah, it was interesting. There was a lot of a solid month of not going above free. Yeah. I'm not surprised. I was out by the Air Force Base, so if you guys are familiar with that part of there. And I was showing the wife around because she hadn't been out there, and I'd been out there once. I took her to a little place called Marion's. I actually put some stuff up in the food channel for people. There's this place Marion's Pizza. They do really thin pizza, and that's good. But they also cut it. Me and the wife were talking about this. Like, I don't know if any of you have kids, but if you do have kids, when you have kids for a party, kids will take a whole slice of pizza. If you've got a pizza like this, they'll take a whole slice of pizza, take one bite out of it, and just throw it on their plate and just waste all the rest of the pizza. So if you've ever like taken kids somewhere and you got a lot of kids for a party, this is like the best little idea I've ever seen, because kids can just have a 1 or 2 bite little slice of pizza, and then if they waste it, you know, whatever. And I'm a dad, so I'm just gonna walk around and eat all of it anyways. Don't get me wrong, but I'm saying you don't have to waste don't have to waste as much. Wi-Fi from Phoenix to snow in January. I don't go visiting New England. Yeah, fair, Kevin. This was actually this training I had to give was a it was a contractual requirement, and I was supposed to give it last year. Like I was supposed to give it in like March, but we kept kind of pushing. There's some power and cooling problems in the space where we were putting it, not because of our system, but because of capacity planning and that kind of stuff. Specifically, there's a company called Motivair. If you guys ever deal with Motivair doors, they're great tools, but they just they have liquid cooling to the door that's actually in front of the system, and then they back pressure the whole rack. So it's an interesting thing. Yeah. Oh, Jay Watson. Yeah, Marion's Pizza. Me and the wife ate there twice when we were out there, but I think I ate 3 times out there last time I was there. Work makes, yeah, it was only for work, Kevin, for sure, 100%. And then so this was Marion's. I love the pizza. And then this was a little thing called like the dive bar. It was called like the dive pizza bar. This place was pretty good. They had more of a thicker crust, not quite deep dish or anything, but thicker. And then this was a place out there called I don't know. This was right by the Air Force Museum though. But it's like that was my wife's food and that was my food, and we did not expect, like, we should have split one of these. But it was pretty good. I couldn't even finish. I mean, I finished all the chicken, but I couldn't finish all the rice with this. So I'm a thick crust fan too, watchmakering. Although anymore nowadays, I gotta watch my carbs and all that kind of stuff. But you know, it's just not as good for me or whatever. Something like that. Some high calorie type thing. But all right. So what we were doing, guys, is we were making these docs. Hold on, let me go look at 14. So we are making the worksheets done for the automation course, because the automation course has been done for a few weeks. I just never finished the documentation. I've been kind of working on other stuff and not getting the stuff I needed to done. The discussion posts were done though, so people can go and do that kind of stuff. We get it. You like pizza? Yeah. But don't know how to order Chinese. So we got there 10 minutes after the lunch was done. If we had been there for lunch, we could have had like a normal lunch portion and gotten all the other, because lunch at a lot of Asian places is like they'll give you like the egg drop or the hot and sour soup, and then they'll give you like it's just a lot more like little stuff with the food as well, and then a smaller portion. Yeah, that was just way too big. So don't get me wrong, I still ate it all. Different Dagger said, I had no drive to write manually scripts anymore. Claude does it all. Mine are, yeah, fair enough. I'm kind of that way with Ansible. I know what I want to do, and then in, like, even my VS Code with Copilot, it'll write what I want it to do, and then I just go modify it the ways that I kind of need to. Kilobyte 808, how's it going over on the YouTube side? We're not working super hard. I'm just kind of on here, hanging out a little bit before I have to do some college stuff. Well, so I do college study sessions on Saturdays for my students. It's kind of like my office hours, and all of the professors do it, so students can go to any one. But I try to do a lot of subnetting with my students, so really hammering them like in the engineering space. I do that with you guys sometimes as well, but I mean, people, it's hit or miss. So I'll probably in the future have like just networking days for people that want to focus on networking, but since I'm just cleaning up the automation stuff right now, this is kind of where we're at. All right, so automation force. But anyways, I'm not trying to avoid any. I'm not trying to ignore anything here. Yeah, Chinese food is shared even if you get lots of. Yeah, fair. Lamp. Out here in Phoenix, there's a few like Asian buffets that I like to go to that are basically Chinese food, but I don't do a lot of buffets anymore either. Because I've been focusing. I wrestle. Some of you guys know I'm a Brazilian Jiu-Jitsu guy, and I wrestle a lot. So I've been doing like 6 days a week in the morning, but not this last week because I've been out of town. But I've been doing 6 days a week in the morning, just training hard, and it's been like dropping my weight pretty a lot. Like I'm down like almost 30 pounds, which is kind of wild. But I figure I'm going to stop being a high calorie grappler. I'll be like a mid calorie grappler. So to err is human, to never really screw things up takes a computer, to break things at scale takes automation. Fair. That's a good point. Yeah. We were doing so in this training. It was kind of funny because like when you go out and train a system that your company set up like a year ago, there will be differences, right? Deltas between what was planned and what we had done on some of these other. I was showing this earlier. I'll pull this up for everybody. This is kind of the way when we build things, we build a big primary HPC, and that's going to do the workload. That's going to be the prod system, right? Let's even put prod in here. And prod is going to run the jobs, right? Like prod is going to do the work. And then typically we've got a dev system off to the side that's like 20% of the primary. It's got to have some horsepower and it's got to have some functionality to behave like the prod so that we can do dev stuff, we can build apps down there, we can do whatever. Typically users can still get on the dev system, and on the dev system they can just abuse a smaller scale system before their jobs become real jobs out in prod. This is used, I use a system like this at NOAA, right, for weather stuff. Big weather stuff, the weather jobs that we run have to run every 6 hours forever. They always have to be running. So this can't be where we break stuff. This has to be live. And then the dev system is where people test and get their stuff right before it goes over into prod. But then we typically have a parts system over here. And the parts system is just running things that could at any time be cannibalized to keep this thing live. And the reason we do it is because some of you might say, well, why would you do that? Can't you just buy new parts from the customer? Well, yeah, but this is what you think about. How fast do vendors or system manufacturers obsolete or end of life parts? Well, typically like a 3 to 5 year cycle, we move stuff out in the enterprise, but not in HPC. HPC, 5 to 8 years, sometimes 10. I've ran HPC systems up in the 15-year range. So if we have to keep everything the same, we buy it all up front and then we just keep it over here. You might say, well, parts lockers, that kind of stuff. Yeah, we typically still have parts lockers, but it's nice to keep that stuff running, because if you've ever pulled something out of a parts locker and it just doesn't boot, well, so that's kind of what it is. Someone pushed CrowdStrike policy, screwed up targeting. Many Windows servers had firewall. Yeah. I remember when CrowdStrike took 1 billion. It was 1 billion systems that took offline. If you're thinking the one a couple years ago. Yeah, I can't believe CrowdStrike survived that. I just can't believe people were like, they used our production systems in Windows as prod, and they just use our production systems to test on. I was wild. It was wild. Yeah, Kevin, but I knew people that were rolling that back for days. Some of my Windows and actually some of my voice over IP buddies were out doing that stuff to keep their companies running. Yeah. Great time for a live stream, Needs Insanity, while opening WVDs. Nice. Well, Nezo, hopefully this stuff's useful to you. We're just kind of hanging out, and I haven't streamed, I just saw for like almost a month. So now we're just kind of on here. Lamp Fellow, cool guy. Yeah. But no, this is what I was training the users on. Specifically in the area, this comes from NIST 800-223. I pulled this up a little while ago. And this idea, that the pieces of this are going to be the next course that I kind of put together for Prolog. Is going to be the HPC course. And I can do everything in that HPC course remotely except for give you guys hardware experience. I can't, I don't have the hardware. My company Redline does actually have a lab of hardware, but I do have access to it, but I don't have access to it for other people. But like basically I can show you guys all the components of it, but I can't, we don't have the stuff here. I could probably get a hold of an old switch here and do some high-speed stuff. We could definitely do the file systems. We just can't do them at scale and at speed in any kind of meaningful way. You got hit pretty hard with that big CrowdStrike thing. Yeah, it really hammered the Windows side of the world, which when that hit, I had just left. I had been the platform engineering lead for AAA for a while. Some of you guys know that. And when I was over Linux and Windows systems. So that probably would have hit me pretty hard. On if CrowdStrike it has, but I'm trying to think, were we running CrowdStrike back then? I know they run it now, but I don't think we were running it there. I'm hoping to make the HPC course good. I have a lot of stuff in there. Can I buy a data center? No, I don't have that kind of money. I do have money for my own little. I have my own little rack at home here, but I don't have like new hardware in it or anything cool like that. I could probably get a hold of an older Mellanox switch, but a lot of times those things keep up a lot of their costs. If anybody wants to read the publication for NIST, here you go. This is some light reading. It says right at the top. I'm gonna drop it for you guys on YouTube as well. It says right at the top that this is a what is it? It's a obsolete or a pulled draft. Where's that right here? It says right at the top. Withdrawn, yeah, that's what it is. But the thing is, this is still super relevant. This is still how we've been building supercomputers, all these components, for the last, God, longer than I've been doing. I've been doing it for 25 years in the supercomputing space. But and high performance compute is the system of compute, but you build supercomputers. So the supercomputers are just a bunch of systems aggregated up to pretend they're one system at the end of the day. It's almost exactly the opposite of, it's almost the exact inverse of what virtualization is. All of this is one system at the end of the day. We're treating it like one big system. All right, let's do this. Anybody that came in late, I'm putting together the labs and finishing up the worksheets. The worksheets were all ready, but they just didn't have the lab links. So I'm finishing up the worksheets and publishing them so that the writer's room can get the structure in for our course. If you guys have never seen our course, where's that at? This is a free course. We have all of our books online here. In fact, if I made this a little bigger, you can see across the top here. Should be, yeah, here. And let me go back one. Yeah. Typically, if I make this a little bigger here, it'll pop all the way across the top. Yeah, so here's all of our courses. If anybody needs these are, again, they're free, but I'll link them to you guys that want them. Free as in beer, right? Not free as in, no, it doesn't cost anything to do the courses. But we've done all the way through Unit 16. I just haven't given the guys the worksheets to keep moving in on this. Plus, I need to record 11 through, yeah, I've only recorded up through 10. So you guys can go look that up too. That's on the YouTube side, that's a playlist. So I have all my stuff in here. Thousands of, as we're harden, you know, going and running Ansible playbooks and looking at what's going on in there. All right, anyways, that's we don't have to watch me. That's not the point of this. Where was that? Yeah. Anyways, I wanted you guys to see all that, and also the guys have a pretty good idea. Colchis, I don't know if you're still around. You know what? I should tell Colchis, where's he at? Colchis. About putting. They wanted to do the blog, right? So I was like, that's cool, put a blog together. But I was thinking you should think about putting your weekly activities in there. Maybe assigning to someone if they're interested to write notes of, right? And then somebody could keep notes or whatever, and then they could put it on the blog if they wanted. All right, yeah, because we don't really have anything in the blog. The guys just put it together. But all that stuff's out there. Let's look at week 14. I know I'm kind of bouncing around, but it's because I didn't really have much of an agenda. I just really do want to get this stuff done so that the guys are good. All right, Unit 14 was around, so it was the technology adoption matrix and make versus buy versus adopt. Like, what do you think that looks like in an industry? What does that look like for a customer? What's likely discussed in a meeting like that? So you're probably not going to get called into something like this early on in your career, but this is going to be dictating, well, one, this is going to have dictated all the decisions before you got there, but also going forward, like, are you going to make software, are you going to buy it, or are you going to adopt the software? And adopting is a term for where we bring in open source stuff. We didn't have to make it or buy it, but we are adopting it, and by adopting it, there's a lot of it's not really correct to say technical debt, but there's a lot of stuff that has to be learned. There's a learning curve to all software. You know, there is a massaging it into your environment, because it's not going to be bespoke like something that you make. You make software, it's going to be exactly what you want. You buy software, it's probably going to be like 80% of what you want as a general rule, and then you're going to have to move some stuff around. But if you adopt stuff, and especially in the government space, we can only adopt things that we can buy support for. We can't just adopt any willy-nilly thing out there in the world. It doesn't work like that. All right. Unit 14 discussion. So your team has a wide variety of open source tooling that they use for monitoring, but you're trying to streamline that. Where might you go? So landscape.cnf.io will tell you projects that are either incubated or graduated and are part of like an ecosystem. Like we talk about ecosystems. One of them that's big is, oh, whoops, that's my Grafana. Grafana.com. So you just go to Grafana.com, right? And you go to, you're looking at Grafana as a tool, right? And you're like, all right, well, what's out there for Grafana? Well, they got this LGTM stack, which is logs, Grafana, traces, and metrics. Those are the things like logs, traces, and metrics are the three things that we monitor. So that's the full stack, right? So this is Grafana Cloud. But let's see, just in their open source stack, they've got Loki, Tempo, Mimir, right? And then Pyroscope. I've never even used some of these. I've never even used this either. Grafana Bela. I might need this for something I'm doing in my dissertation. Grafana Faro. So there's all these things. Grafana Alloy has superseded for the Prometheus pipeline. We used to use Promtail to feed into Prometheus, but now we use Grafana Alloy. And then we've got Prometheus. Prometheus is kind of, I wouldn't call it the king. There's other good time series databases out there that are doing good stuff, but Prometheus is one that's directly in the ecosystem. So if you were answering this question over here about we want to like streamline it all and turn it into one set of tooling, you might say, well, we already end with Grafana. Everybody ends on Grafana, but maybe I need to use Loki and Prometheus as my middle stack. Where's my, let me pull this up real quick. Some of you guys have seen this before. When I kind of walk through this, let's open up my, where's my monitoring? Yeah. So when I show this to you guys, this is my monitoring stack in my home lab, right? You've got an ingest tier, you've got a storage tier, and you've got a presentation tier. That's kind of the way that I think of monitoring. How are we getting, how are the data flowing out of our systems? Are they pushing? Are they being pulled, right? And then where are you storing it? What's your middle tier for storage? And then what are you doing over here for your presentation? Yeah, I need to move over to Alloy as well. In fact, I need to make that into a lab, Cole, because we have the older lab with Promtail to Loki, but I want to do one next to it that's like, hey, that's the older way, this is the more modern way. And then, yeah, I need to do that. So I do need to get in there and do Alloy. Where is Alloy? I don't even see Alloy in here. It's definitely one of them, guys, but I didn't see it there. Maybe I was being dumb. Oh, there it is right there. I was just being dumb. By the way, they got GrafanaCon coming up. There's all kinds of stuff going on. But logs, traces, metrics, yeah, Grafana really aligns with a lot of the ways I think about monitoring as well. So I think they're a great tool for that. All right, guys, I think the wife's home, so I do have to go here because she was bringing me some foods. Let's say that I'll probably be back on later, but if not, I'll definitely be doing some Linux type stuff down in the Discord. We'll be doing the admin course. I have a lot of stuff to clean up in my home lab. I've got a lot of stuff to move over into my, oh man, that thing's like a 6-month-old Proxmox server, and I don't even have hardly anything running on it yet. So we need to do some stuff in that space as well. I also need to work on the dissertation, so all of that stuff will be coming up. And I definitely appreciate everybody coming by, and I will see some of you guys later on this week. Take care.